Okay, and then if Caitlyn, you would like to go next.
Sure, can you hear me?
Yeah.
All right, sounds good. My name is Caitlyn Clark. I'm a postdoc at the National Renewable Energy Lab. I've been here for about a year and a half in a postdoc capacity. I also finished my PhD here. So I've been here for a while now, off and on for maybe 3 years. My work focuses mainly on incorporating risk, reliability, and resilience into our suite of design tools that we have here at NREL. One that I work mostly on is reliability-based layout optimization. So I know layout optimization is part of the collegiate competition some years. And it's kind of doing what that's doing, but pulling in what Jessica Fischer does. So looking at how drivetrains fail and trying to organize the turbines in a farm so that they can fail maybe a little bit less.
Awesome. And then Brodie, if you would like to proceed.
Hi, everybody. My name is Brodie Dockendorf. I am an operations manager for EDP Renewables. I currently run a small 98 megawatt utility scale wind farm in southwest Wisconsin called Quilt Block Wind Farm. Oh, my notes just went away, so I'm just going to wing it. Anyways, I've been in the industry for about 15 years. And how I got into the industry, I kind of, believe it or not, I just kind of stumbled into it. I was driving around Clear Lake, Iowa one day with my wife and kids, and I just happened to see something right over the top of the trees. Just, I couldn't tell what it was. And so we drove outside of town, and just happened to, as we came around the trees, I could see all these wind turbines in the field, and I'm just was blown away at, you know, no pun intended, but blown away by just the coolness of the whole thing. So we actually like drove right past the do not no trespassing, do not enter sign, drove right up to the base of the tower, got out of the car, and I'm looking at this thing in amazement, and I told my wife, I said, you know what, I have to work on these things. Like, I got to figure out how these things tick. So needless to say, fast forward 3-4 months, I found out there was an opening to work on them. They were looking for wind technicians. I didn't really know what that was, but I figured I'd figure it out, and I got a job working on the turbines. Spent, you know, basically 10 to 15 hours a day working on turbines for about 3 years, well, about 2.5 years, and switched sites and worked at a different project. And next thing you know, I heard they were looking for an assistant manager, applied for that job, started running a wind farm, and I've been doing that for about 13 years now. Actually managing wind farms for 13 years. And now I oversee the operations and maintenance of the facilities. I make sure the quality, our contractors are providing good quality services and doing things on time and maximizing the performance of the site. So I spend my days just making sure everything's moving smoothly. So.
Awesome, thank you so much. Now with that, we could move into our questions. I know Brodie kind of touched on this during his introduction, but our first question is what your educational backgrounds are, and what types of opportunities you guys sought out before you got your position in order to like enrich your knowledge of wind energy.
Well, I can go ahead and start since I was just talking, but so as far as my educational background, I was really fortunate to get involved in wind when I did. Now, 15 years ago, the economy was great. It was actually really hard to find, the industry was extremely small, and it was really hard to find people that were, one, willing to climb 200 some feet in a turbine, you know, climb a ladder, because, you know, we didn't have elevators or, climb assist at the time. And nobody really wanted to do this level of work. Now, my background was actually, I came from the masonry industry. I was a forklift operator and a crane operator, so I had experience working on, hydraulic equipment, and I knew the ins and outs of, rigging and stuff like that. So those were the skills that I brought to the table as a technician. So, so really, I just had a high school diploma and got into the the maintenance aspects of the turbines. And then I slowly started working my way into the management side, which for me was probably a little more exciting than the actual working on the turbines. So that is my background.
I can hit it next. So I have an interesting path, but it's all wind. So my college that I went to, SUNY Canton, had some renewable energy courses, and that's what drew me to the college. Ultimately, I ended up majoring in mechanical engineering technology. Totally loved it. I first fell in love with wind actually touring my college because we happened to detour through a small town that has New York's largest wind farm currently. And they were on the horizon, just completely mesmerizing, and I totally fell in love, and I knew that that was really what I wanted to do. So once I got into school, I really tried my hardest to get wind internships while I was in school. And I think the internship that, well, really was a volunteer program that really shaped my career was something called the Wind Aid Institute, and it's located down in Peru. And it's basically a volunteer program that allows you to manufacture small-scale wind turbines completely from scratch. So we were doing, fiberglass laying and modeling and, actual building blades. Thank you, Willa, for putting that link in the chat. I learned how to weld while I was there. We did some structural components. We hand spun electrical coils for our rotor stator assembly. So it was this massive hands-on project that I was introduced to from a friend of mine, which, shout out to mentorship. If you guys don't have mentors, would highly recommend. But essentially, so that experience really kicked off my career in wind. I did that for 4 weeks in between semesters, my junior year, between semesters, my junior year. And then after that, I ended up in offshore wind research at UMass Amherst as a research experience for undergraduates, which again, highly look into that if you're interested in any sort of research experiences while you are an undergraduate. And I realized I didn't want to get into research, and I really didn't like coding, and that was a lot of my research, so I decided to take it a different track. And actually, once I got out of college, I took another internship before starting my full-time job in drivetrain testing, and I actually worked for EDP Renewables, kind of close to Brodie, actually. I was at Top Crop Wind Farm in Dwight, Illinois, and I did a 10-week wind turbine technician internship there because I wanted to better myself as an engineer, and I felt that having the experience of a wind turbine technician was going to completely revolutionize my views as a potential design engineer, especially for repairs, serviceability, all that type of stuff. So I did that and had a complete blast. Would highly recommend fieldwork to anyone. I'm a big supporter of fieldwork for sure. And once my internship was over, I had already secured employment with Clemson University's Drivetrain Testing Center. So I headed in that direction. And definitely, I think one takeaway for me from an internship perspective is the more hands-on experience you can get, the better. And I think from the technician internship that I did, because it was after I graduated, it's still okay to have an internship after you graduate. I know, we probably have a lot of seniors on the call, and you might be struggling to find a full-time job, and maybe not looking at things like internships. But I feel like, for me anyway, I wanted that technician outlook on life, but I didn't necessarily want to be a technician full-time. So for me, that type of a setting worked, where it was this very short-term, specific goaled internship that was going to further my career. So I would highly recommend that from an internship perspective, but I definitely did quite a bit when I was in school. And it was all wind because I knew that's what I wanted, but yeah, so that's it.
Thanks, Jessica. Caitlyn, would you be willing to talk about kind of your path next, since Jessica touched on some of the research?
Absolutely. Yeah. No, they're making me go after Jessica. She's quite the superstar. I can only speak to research and graduate school and the academic path. So I'll just do that. I got into wind through looking at wave energy. I don't know who's familiar with wave energy, but I started as a marine biologist working in environmental effects of wave energy as an undergrad as part of one of these REU programs, and then started taking grad classes by the end of my undergrad because I had kind of decided that that's what I wanted to do, is some coastal and offshore engineering stuff. Applied to grad schools for a year, took my FE exam, worked for an environmental consultant, and then went back, made a big shift. So I started out in ecological engineering. So in my professional life of a different life, I was designing wetlands, designing river and riparian systems. And then in grad school, got to take a moment to shift perspective. So went into mechanical engineering, and that's where I started doing a lot of wind stuff. So as part of my graduate work, I've worked under Avangrid, worked within the Fulbright Association. So went to Denmark for a little bit just to see how they were approaching reliability and design in wind turbine systems. And then as soon as I got back from Denmark, came to NREL, and I got linked up with NREL because I had an idea for a project, but I would need NREL's help to do it. And so I sent my project idea along through my graduate advisor, got a 6-month internship, and then came back 3 months later to finish up my PhD, keep running with it. So, so that's my path.
Very cool. Thank you for sharing. Colton, would you like to talk about kind of your experience?
Yeah, I'll be a little bit brief because I'm getting very dunked on with the other panelists here. I'm not going to really speak down to anyone, mostly just because I don't quite have like the to be doing that. Again, I was class of 2020, so my story is a lot shorter. COVID hit the world, as we all know, probably like around a year ago, starting to sort of be a thing. I was in the Collegiate Wind Competition as one of the lead PMs. We were like seeing the writing on the wall, like, oh crap, this competition's going virtual. And at that point, like, we kind of rallied the troops and we were like, okay, we can either just like coast this in, do whatever, we'll probably get an A because no one cares. But we decided just to like send it, and we ended up winning the competition, and that's kind of the impetus to what got me a job. Yeah, it was really cool. So I used industry connections to reach out to Scout Clean Energy with some alumni via JMU. One of the guys was the director of development. He liked our commitment to the process. We were even doing work on our virtual graduation day and like through into the summer for this competition. The second we found out we got first, I found out I got a job, and it was just like, pack up your bags, you're coming to Boulder. And I've been working with Scout Clean Energy since then. So if you guys are in the, can I get a show of hands, who's in the Collegiate Wind Competition right now? I'm assuming it's going to be, yeah, okay, cool. Good on you guys for continuing it this year. It's definitely not an easy environment to be working in with the remote setting, but if you really put some time in, it's really cliche. And I think Jamie Mears, one of my colleagues, mirrored the sentiment. You get in what you put out, and I can 100% speak to that and attest to that. So good to see you guys here.
Awesome, thank you so much. So it's like very obvious you guys have so much experience in what you do, but like how did you guys go about learning the training aspects of, or like the most technical parts of your role, and also what are the most technical aspects of your role, and how did your company go about training you or developing your knowledge?
I'll kind of do the snake approach here, so I'll kick this one off and send it back around the horn. For my job as the developer, it's a lot of ALTA reports and legal documents. You got to make sure that you're representing 100% accurate information, both to the county and to the landowner, and that you're being consistent from document to document, from team member to team member, from time period to time period. And doing that requires a lot of deep reading. So there's going to be some days where I'll maybe just sit down with a big stack of paper and just like confirm some stuff. And like there may be like 2 highlighted errors throughout the whole thing, but we have to catch those errors in order to progress smoothly. So I'm assuming you guys are like copying some projects for the Collegiate Wind Competition, reading some like environmental reports, environmental assessments and all that. And that's a good start. Getting the legal document and professional drafting experience is very important within a technical industry.
I can pick it up from there. So I think a lot of wind, I can definitely say the technician roles, and I'm sure Brodie will echo this. A lot of wind companies specifically will invest in training for you and often do some on-the-job training as well. So don't be alarmed if you feel like you might not be as qualified for a position or anything like that, just based on a lot of the qualifications. But I think from an engineering perspective, from a technical kind of what am I doing in my role, I am doing a lot more design than I anticipated to do. So things like machine design, some statics and dynamics. I'm actually running calculations in my job, and I never thought I would actually be doing that, right? I mean, all of us sit in these classes and we wonder, like, are we really going to use some of these concepts, and do I need to know everything? And I think really starting out in a career and starting out in the industry, everyone knows that you have, you know, this foundational knowledge and that you need to use it to grow with it. So that's a lot of what I'm doing right now, is kind of refreshing my knowledge on those fundamentals that I've learned in college, and then applying that to specific, you know, applications to do tool design specifically. And then I think also from just a general plug for certifications and whatnot. I know I did like the OSHA standard 10-hour general industry course, and that was relevant to wind, that I think anyway. But again, we do go through a lot of our own safety training and whatnot. And then from an FE perspective or a PE perspective, I know Caitlyn talked about getting her FE exam completed. And I think that really keeps you up to date on a lot of the kind of things you might use in the industry from a high level overview of those types of questions. So I'd highly recommend the FE exam as kind of a refresher on just what you went to school for, what you know. It's a long refresher. It's a 6-hour refresher, but you know, training for that and, you know, running practice problems and all that type of stuff is definitely super helpful, or it was, at least for me, when I did my FE before I got in this role.
Caitlyn, would you like to go next?
Mm-hmm. The most technical parts of my job, let's think about this. I do mostly software design, and I incorporate different component models into that design. Sometimes I play around with optimization algorithms, machine learning or AI stuff. So that's mostly the most technical part. I received PhD training on that. So I know this is super straightforward, but I guess that's what I have to say about a research career or an academic career. If you're interested in grad school, if you're interested in management or just taking on more of a design or leadership role within different companies or institutions, like academic institutions like NREL or a university, usually a master's degree is required. And then a PhD is required in some cases. So don't do a PhD just because you don't know what else to do. Don't do a PhD because you think you might need it. Definitely look at what careers you want to pursue and see if a PhD is required. And if it's not, then a PhD is not worth your time. It's gonna, you know, you could be making money in those 4 years. If you are very academically driven, like I am, then the PhD was worthwhile and fulfilling anyways. So I would encourage that. But the PhD is, I look at it as an opportunity to learn as much as you can about a certain subject, to develop your skill set through different projects. I had a very open-ended graduate project. And so I was essentially brought in and I had to fight for funding every year, but every year I got to propose something new and different, something that built on the skills or expanded my skills from the year before. And so now that I'm at NREL and I have kind of this core base that I was hired on for, I'm able to apply those skills elsewhere. So for instance, I'm working in hybrid renewable plants, in that kind of design, but I get to apply my reliability knowledge. I get to apply some of my systems optimization techniques. So more software development, as well as some reliability engineering piece there. Yeah, I would say that that's the most technical, the most used skills of my job. Software development would be up there, but I think I want to impress that I also commonly communicate and coordinate, apply for proposals, manage people. So don't underestimate the non-technical skills. Some of the best work that I've created with others has been through transdisciplinary projects, and that mostly requires you kind of impressing people every meeting you have with them and eliciting the best out of them too. And the only way you can do that is through coordination and also inspiration, right? Inspiring people to stay coordinating with you, and giving them clear direction. So that's what I have to say about my skill set.
Great, thank you. Brodie, would you like to go?
Yeah, you bet. So as far as the training goes, to Jessica's point, you know, a lot of the industry, they're going to train you, especially on the technical aspects of the machines, and you know, and even in general, we have a lot of new people coming to the industry with no wind background, and we have training for just about everything, as far as like teaching in the industry and just kind of the high level. As far as like my training goes, again, I got into the industry 15 years ago. I was one of 4 brand new technicians on a wind farm that all the other technicians had just left. So they taught me how to climb a turbine safely, handed me a manual and a wiring diagram and said, go figure it out. So that was the extent of my training. So I learned on the job, under fire. I remember calling a guy one time. I was having a problem with the turbine, couldn't get it running. And I called him up and he said, you know what, Brodie, I don't have time to talk to you right now. You're just going to have to figure it out yourself. And from then on, I never called people. I just did exactly that, just figured it out for myself. A lot of my success, I guess, just in general in life, has been to just not give up and go after it. And, you know, if you go after it wholeheartedly and you never give up, you'll never fail. And you don't fail until you give up. And I guess it's been my mantra throughout my entire life. And I guess a lot of why I got to where I am. And just picking up on how the site operates and constantly learning. There isn't a day that goes by that I don't learn something new and take note of the things that I learned. So from the technical perspective, you know, just learning the turbines, again, I figured a lot of it out on my own. And again, we do offer nowadays, every company you could work for has some level of training, whether it's technical or, you know, even the way the company does business. Every company is different, you know, depending on who you go to work for. So.
Great, thank you. I'm glad you were able to get through it, even despite not having as much mentorship. But you kind of touched on success in your role, and you had more of a personal sort of success that you felt for yourself. But in addition to that, how did your like management measure success, and what are the opportunities for growth that are within your sector?
So as far as like how we measure success now, like a lot of it depends on how my site operates and how I manage the site within the parameters that the company set. So for example, we have a whole list of standard operating procedures to follow. This is how you operate the site. These are the certain things you have to have done every day. And there are certain metrics that are set out every year that says we're going to have, this availability for the year. Of course, no injuries on site. Safety is a big thing in the wind industry, just due to the fact that everything we work around is extremely dangerous. We're working at heights, we're working with high voltage, we're working with mechanical. So again, we look at the stats of the site, how the site's operating. Is it operating safely? Are you following the policies and procedures? And that's basically how corporations are measuring, the success of, your individual success. As far as like the way I measure my success, I hold myself to the highest standards. My company might have the bar here, but I tend to raise the bar up a little bit higher for myself and for my employees. So, and that's just because I'm extremely competitive and I like to have the best running site. So, but that's me. So.
Jessica, I saw that you were nodding as Brodie was talking. Are the successes defined similarly for you?
Yes, I would definitely say they are, especially the point of safety, right? So as a repair engineer, designing processes, designing tooling, that's the number one thing that I think about, right? Is I want to make sure that these tools are safe to use and that we're not putting anybody at risk by putting this process or putting this tool out into the field. So from a job specific perspective, and again, even just industry wide, safety is just absolutely, we want everybody to go home to their families every night, without question, obviously. So that's a really big one, right? That the whole industry takes into consideration. From my role specifically, definitely the safety aspect from a specific program is huge. And then also, obviously, our biggest goal is we want to put something out there that is, done right the first time. So we go through a lot of due diligence to make sure that, our tools are appropriately analyzed for certain loads, or we have them that are ergonomically easy to install. Things like that really are what we look for in programs. And then from a personal perspective, right, I think the analogy of setting the bar high is a great one. But I agree with that, and I find myself putting a lot of pressure on myself to do really well in a position like this. So it's definitely an interesting balance to say, I really want to exceed expectations, and, just making sure that you're not, kind of demoralizing yourself by trying to do that and put too much pressure on yourself. But yeah, no, I definitely echo the kind of raising the bar point for sure. Because I think that's huge. If the biggest thing that everyone says, right, is if you find a job that you love, you never really end up working. And I think that is a huge ticket to success, right? You want to be doing something that you love. And truly that's what I'm doing here. So.
Great, thank you. Caitlyn, would you say in the like academic setting, since you're often competing for grants and submitting proposals, would you say you would measure your success more in that aspect as well as like setting your own deadlines for completing projects?
Yeah, I think it aligns pretty well with that. I know NREL in particular, I think most academic institutions judge your productivity as having publications and bringing in money, which is very superficial. It's not actually all that, but those are the two easiest metrics for them to measure. Therefore, those metrics get managed, right? So that's what I would say success is termed by. And then underneath that, you have all the skills, all the successes that build to those points. So successful collaborations, managing projects appropriately, building off of each other. So having projects from disparate sources or disparate focuses that can create a portfolio that you can then present to the Department of Energy to say, listen, this is really important. We need to look at this more. Yeah.
I just have a quick follow-up question, Caitlyn. So how does the generation of new knowledge kind of fit into the scope of like what different aspects of success for kind of research and the academic side? I think.
What was the first part of your question? The generation of knowledge?
Of like new knowledge. I think that's like what I commonly, personally, I see as like, oh, this is what you do if you're in research or in kind of the academic side of things. Yeah, how did that?
Absolutely. Yeah. Well, we can't really, we have this tough thing at NREL where we're not an academic institution. So we do a lot of work for others. We do a lot of work with industry for industry, which is kind of why I'm at NREL in the first place. So the generation of new knowledge, what I find, I like to frame it in a value chasing approach instead. So I'm consistently trying to talk to stakeholders to figure out what it is that they're interested, what problems they have, what keeps them up at night, where is painful to them. And then usually there's some kind of tool that we can either create or some knowledge that we can create, like you said, new knowledge around that problem. So bringing it to attention, figuring out its impact, and then figuring out ways to solve it is usually how I like to look at it. There are some areas in which we're behind at the national lab compared to industry because they've got boots on the ground, they know the issues, and we just don't. And sometimes there's a level of proprietorship that separates us from knowing those issues. So that's also something to keep in mind. But yeah, we try to create new knowledge to help others, and we always are trying to advance the field. So does that answer your question? Sorry.
Yeah, that does. Thank you so much. That I really like the reframing as like value chasing versus generating new knowledge in a vacuum. I think that's really insightful.
And I guess that leaves me. I'll be super brief with this one. I'll just say in the development world, no fire drills allowed, if that makes any sense. So it can't be like 11 p.m. day before some submissions due to the county and you're scrambling to get it prepped. Granted, sometimes things are out of your control, but if a human error causes that, that's no good. The name of the game for us is just keep it very steady Eddie. Nothing crazy happens, nothing pops up, no fire drills, no nothing. So just making sure you're on top of stuff. Big.
So for our next question, looking at the industry as a whole, what do you think are the latest upcoming advances and challenges coming to the wind energy industry?
So I can start. Oh, sorry, Colton, you go ahead. Are you sure? Okay. So I always plug for services. So it's not necessarily anything new, but it is something that is going to be around as long as we have wind turbines. So we might hit a threshold where, you know, oh, we hit the 20 megawatt mark for offshore, but we can't get any better than that, right? Or we can't get any bigger than that. So, you know, offshore obviously is huge right now, but, you know, we have turbines that are, you know, 20 to 25 year, almost 30-year lifespans. So what do we do with them across those 30 years? And I think something that we're doing on my team is something called design for serviceability. So all of the new units that we're putting together, we are actually designing serviceable qualities into these wind turbines so that we don't have to have repair technology teams like the one that I'm on coming up with all of these innovative ways to do unique repairs with external cranes or bringing in different equipment, all that type of stuff. So for me, the serviceability aspect of everything is probably the most longevity aspect of wind. But beyond that, I think also offshore is going to be absolutely huge in the next couple of years once we start getting these massive projects in the water.
I know that offshore wind is a big kind of issue for development. Colton, can you talk more about kind of where you see the industry going, whether it's offshore or elsewhere?
Yeah, offshore is kind of the new hotness, mostly just because you get more bang for your buck, so to speak. You have higher upfront capital, but you get a lot of energy out of it. Jessica touched on this. Decommissioning is a big issue for us right now. A lot of counties are really looking for a really stringent decommissioning report because after 30 years, they want to make sure that those pretty big fiberglass structures and carbon fiber structures and composite structures have somewhere to go. And industry is definitely lagging behind where it probably should be for those, but people are very rapidly adjusting to get that sorted. So decommissioning, and then I guess PTC credits, but that's a whole other topic I'm not even gonna like open up. I would say PTC, offshore, and decommissioning, 3 pretty big buzzwords in industry right now.
Caitlyn, how does your work at NREL kind of align with the next steps that Jessica and Colton have outlined, and how does it differ?
Mm-hmm. So my particular specialty I mentioned was incorporating reliability, risk, and resilience into design tools. So trying to design from the beginning exactly what Jessica's doing. So for serviceability or, avoid failure or make them less severe when things do fail. So I actually have a dozen questions for Jessica after this phone call if she wants to get on with me. Yeah, I think the way I like to describe it to people is that design, which is kind of where we've put all of our eggs thus far in research, is offense. But what wins championships, right? Defense, the reliability bit. So you can design your wind turbine to create energy, but you have to protect it. You have to protect the goal. And I think that's going to be increasingly difficult in offshore, certainly, because there are these different serviceability or accessibility issues. I also think hybrids are something that NREL currently is behind on, and we're trying to catch up to industry. But hybrids are definitely another big thing that people want to add solar panels to wind farms, or if you're looking from an armed forces perspective, you're trying to do the opposite. They have a lot of solar, but they want to increase their renewable energy capacity, so they want to add wind. But there are some underlying issues that bar us from doing that. For instance, right now, hybrid plants are restricted by the interconnection queue, essentially, just for them to hook up a plant to the grid. What else? Yeah, just some issues around that where there are political or financial forces that are driving design decisions, and we're not accounting for them as much as we should. So I would say those two are certainly an issue as well. I know people are really behind the direct drive offshore idea, but it is yet to be proven to be more reliable. So I'm going to be really interested to see how that data shakes out. I think probably mid-size gearboxes are another really good solution. So gearbox and direct drive designs are both advantageous in their own ways, and they both have faults in their own ways. So there's that. And one thing that I am learning increasingly about, and I'm so glad that all of you are interacting in the Collegiate Wind Competition right now, is that even though there's a lot of development planned for the US, our port infrastructure and our workforce are not prepared to realize that as it is currently in its current state. And part of that has to do with safety training. So even maritime academies are trying to get their trainers trained, but they have to go to Europe to do that. And right now, COVID's blocking everything. So again, non-technical issues, but still enormous hurdles that are going to cause some pain points throughout. So it's great that you all are learning about wind energy. It's great that you're all training yourselves so that as we try to realize more and more wind in the US, whether it's offshore, onshore, bigger, multi-rotored, whatever, that we are able to service that.
Perfect. And then I have a kind of backup question that Brodie, you can feel free to address as well. But you could also go into the other aspects of it. But I was wondering how big like policy incentives and like corporation management, how big that is on preventing like hybridization and wind farm development. Because I know there's, in the United States specifically, there's a lot of policies and stuff that prevent you from being able to achieve stuff.
Mm-hmm.
Oh, go ahead.
Go ahead. Sorry, Brodie, did you want to go first?
Yeah, actually, I was just going to kind of touch on that just briefly too, and in my response to, as far as the advancements go, up until the current administration change, the industry was really kind of looking at slowing down in wind, at least onshore. Offshore is still big under development. There's a lot of stuff underway. But with the recent change in administration, I believe we're going to see another, I guess, and these are all assumptions on my part, but I would assume we're going to see a shift more towards wind than solar. Initially, we were looking at, a lot of companies were looking at going towards solar and kind of backing off on wind just because, cost-wise, and the administration didn't really support it as much. But Biden has some big plans for renewable energy, so I'll be really curious to see how things shake out. I know, just from an industry, from where we need to go from an energy perspective, and these are my opinions, I think, we really need to see some advancements in storage, and storage is going to help us achieve that, I guess, open up an opportunity to become, 100% renewable. And I believe we can get there, and that needs to be our goals, but it's going to be more than just wind. It's going to be more than just solar. It's going to take, to Caitlyn's point, there needs to be the hybrid, and there needs to be a balance between storage, solar, and wind. So, and the more we can advance in those areas, I think the better off. But, we've been chasing a lot of old technology for a long time, trying to improve it. Hopefully there's the next best thing around the corner. Maybe one of you guys have that idea kind of floating in the back of your mind and can come up with, something even better than what we have now. So that's all I have.
I think that's a great point, Brodie. I think storage is absolutely necessary, especially in these hybrid plants, and especially from a resilience perspective. So like we just saw in Texas last week, as well as in other areas across the states, and over the last 10, 20 years, we have an aging grid, and we have some resilience issues as our grid modernizes in some ways and doesn't in others. So we do have a bit of an infrastructure crisis in some areas of the states right now. So I'm really looking forward to see what the new administration does about modernizing our grid to sustain all these renewable energy technologies that we currently have. Storage is definitely one way to do that. And yeah, will be a key piece of that, but also, updating these lines or enabling the grid system, both at the distribution and transmission level, to support advanced controls or distributed controls, controllable devices. That's autonomous energy systems. Like, we need to be really utilizing the robotics that we have at our disposal And right now our grid just can't deal with that at the moment. And it's going to take baby steps, but I think we can get there.
Awesome. And then before I open up to questions from our guest, what advice would you give to students looking for an entry-level position in the industry? And what about students looking for an internship or entry-level job, especially in this new environment?
So I would say for me, you know, pivotal for my internships and then ultimately my roles after, mentorship is huge. I know I'm a mentor to a handful of people. If you're looking for a mentor, feel free to reach out. I'm totally cool with that. But the wind aid opportunity that I had, I found out directly from a mentorship program. It was actually through the Women of Renewable Industries and Sustainable Energy called RISE. If you guys are not familiar with it, definitely check it out. It's a fabulous organization to support the women in clean energy fields and all of the great things that go on. So if you want information on that, let me know. But I actually found my first mentor through that program, and she introduced me to that wind aid internship, which really kicked off my career in wind. And then beyond that too, I think having a plethora of mentors, I think is beneficial, because the first mentor that I had was actually a PhD student in wind at Cornell. And then I've had other mentors as well in the industry itself, to broaden basically just what the industry has. Because I think a lot of times, at least for me, I did a lot of research early on, just online basic searching of what there was, what I would fit into and all of that stuff. And I know as a professional now, I try and help people find jobs because based on your interests, I know what's out there based on what I've searched for. So you might not know of, you know, Scout Clean Energy, for instance, right? Like you might not have known about them if you hadn't come to this panel, where most people know GE Renewable Energy, right? So there's a lot of kind of lesser known companies that are doing absolutely fantastic work that you could be a part of. You just need to know how to find them. So having mentors that can kind of direct you to different companies or connect you with different people that might know those companies is always a really good thing. And then I think additionally, for me, a lot was just Google search, total like Indeed wind turbine jobs, like not gonna lie. But so that's a good place to start, just to get accustomed to kind of the wind companies that are out there if you're looking for wind specifically. And then internship wise, a lot of the companies have internships, but sometimes they don't advertise. And I think Caitlyn, you might be able to talk to like the SULI program and the REUs and stuff like that for research specifically. But yeah, I mean, there's jobs everywhere. And I think Brodie will probably talk to wind turbine technicians and how we absolutely need people to climb these turbines. So yeah, I definitely had luck with online searching, but also the best part of all my experience really came from fostering a relationship with a really good mentor.
I got two pieces of snacky advice here. One is get tenacious, and two is how are you unique? So if you're thinking from the perspective of a human hiring manager, once you clear that algorithm, your documents are still going to end up on the desk of some person. And when they speak to you, you're speaking to some person. What impression did you leave on them? That goes a long way. You got to just get your foot in the door by any means necessary, and you got to kind of just go for it. There is no like, oh, I'll kind of like half commit, half whatever. No, you got to go for it. Tenacity and impressions are a huge thing in landing that first gig. So get after it. I believe in y'all.
On a different kind of, I have a different question. For what kind of programming do you guys find that your people end up using most? I know that we here in the mechanical engineering use a lot of, or the only one that we're only required to take MATLAB. I was wondering if that's very often used for modeling and stuff like that.
I know at the National Lab, we primarily use Python. If you know how to use Git, that's a big one. People also minorly use Fortran, C, C++, Julia. And then in special, like electrical engineers will always use MATLAB forever. So that's what I would say. The top two used tools that I'm constantly going back to are definitely Python, both in notebooks and, just out of the terminal. If you can code using Bash, that's also a huge one for developers. And then, yeah, if set up now before all your capstone or CWC reports, that you have to write or do, Mendeley and LaTeX. That's what I would say about those.
I really don't use any coding whatsoever. I'm really just hand calcs. We do some FEA analysis in ANSYS, and then I actually do a lot of CAD modeling. Well, not a lot, but enough CAD modeling to conceptualize models for the tool design that we use. And we actually use a Siemens program called NX. And basically it's kind of like Inventor, just harder to use in my opinion. It's not as user-friendly, but it's more 3D modeling than 2D. So I also didn't expect to use that at all. Just totally, like, I love drafting, but I did not expect to be using that right now.
Does anyone else have any last minute questions they want to ask anyone of our mentors?
Yeah, I have, oh.
I just wanted to touch on one thing real quick before we got too far into the questions. As far as getting into the industry, I've interviewed a pile of people, and I continue to interview a lot of people. The best advice that I can give to everybody here is show a genuine interest in the job. And if you have a genuine interest in the job and ask a lot of questions in your interview, I mean, don't be afraid to go into an interview with questions about the job, about any aspect of the company, and do a little bit of research first. Find out what you can find out online about the company that you're applying for or you're going to interview for, and then have a basic knowledge of what they do and kind of, what they're about. But also, again, ask questions, show interest, and really just sell yourself. Don't give up. Indeed, online Google searches, apply for jobs, and get your foot in the door and just sell yourself. So I just want to touch on that real quick because I interview a lot of people. I have people come in, they're just applying for a job, and they generally don't make it just because there's no interest in the position. So that's all.
Thanks. Sarah, what was your question?
Yeah, so it's completely different topic, if that's okay. I don't know if anyone wants to say any last minute thoughts. But since a couple of us are coming here from Houston, I was wondering if I could ask about the recent events involving the wind turbines in Texas and freezing over. And I know that was like completely overblown, but it still did kind of happen. And I was wondering if anybody had any thoughts, because we always hear about renewable energy and wind in the context of climate change mitigation, like what we need to do to stop it. But does anyone have thoughts on like the intersection of renewable energy and adaptation to climate change?
I have so many thoughts on that. So maybe you and I can set up a talk after this because, yeah, we could go for it. But you might look up financial risk disclosures because that's going to become a big thing. And that's what drives a lot of these decisions people are making around the grid and resilience, both with traditional and renewable energy sources. So I don't know if somebody else wants to say something about it.
I can touch a little bit on just weather impacts to wind farms in general. There's several things that tend to cause problems with wind farms. Um, Freezing temperatures and fog, that will greatly reduce the output of a wind farm. It causes just enough ice on the leading edge of the blades to reduce the lift. And in turn, you can take a site from producing full generation down to nothing in a matter of a couple hours. Ice is another big thing. So again, if you get ice buildup on the blades, it causes enough of a disturbance in the airfoil that it basically cannot create lift anymore, and you'll get a reduction in site output, sometimes down to nothing. Cold temperatures generally, so now my sites in southern Wisconsin, we've had negative, let's see, we were down to negative 17 the other day Fahrenheit. So turbines can run in cold temperatures. We have Arctic packages on our turbines up here. Some of the Texas sites, generally they won't invest in the extra Arctic package, just because, quite frankly, you just don't get that cold of temperatures down there. These are one-offs, and I think just in general, I think ERCOT had a lot of generation offline. I read 30,000 megawatts worth of gas and coal plants were offline for maintenance. I think this is generally their low season, low demand season. So they probably weren't preparing for, millions of people to be running heaters, and ended up, coming up short from a generation perspective. I don't know how long the wind farms were offline. If they were offline for very long, I would doubt it, because generally ice tends to clear up in the matter as soon as the temps rise above freezing, and the site can be back online in no time. So again, I don't know a lot of the details of the different site operations down there from wind perspective, but that tends to be what the issues are with weather impacting the sites, especially winter weather. So.
And to piggyback off that, I think a really great analogy on kind of the cold weather packages and the design of that is, if you think about just buying a winter coat and you say, I'm going to buy a winter coat in Canada, you're going to get this fluffy parka. It's going to be super heavy duty for super cold weather. And if you buy a winter coat in Texas, you're going to get, just a light fleece or, something like that. So a lot of wind sites will opt to have these cold weather packages that have, de-icing systems on the blades, heaters, additional aspects of, weatherproofing your wind turbines, if you will, kind of like buying a winter coat. But you're not going to put a winter coat on, you're not going to buy a Canadian winter coat for a Texas winter, that you might only use once in your lifetime. So I think the sad part, though, is because of the climate change, we are seeing more of these extreme weather events in places like Texas. And that really goes back to Caitlyn's perspective of just an aging fleet and an aging infrastructure. And do we go back and retrofit some of these cold weather packages into the fleet that we have in these warmer climates that potentially will see colder climates in the near future? So I haven't heard a ton of, actionable talk about doing stuff like that. But I think if we continue to see these weather events, that's definitely going to be something that we're going to have to consider from an infrastructure upgrade perspective. Because that, in my mind, that really was the bulk of the issues down in Texas.
Caitlyn just shared out a great recording in the chat about ERCOT and the Texas situation, if people want to check it out.
Thank you, guys.
So I don't want to keep everyone too long over. So first I want to thank everyone for coming. Thank you for our guests, and thank you for our mentors for teaching us and helping us. If anyone else has any other questions, they could always email me, and then if our mentors are okay with it, I can direct you guys to them. And thank you. You can find us also on LinkedIn, Instagram, and campus groups if you guys have any other questions or want to know more about our upcoming events.
Yeah, and if industry mentors are interested in being a resource for people, if you could just post your email in the chat as well, we can connect with you that way.
Sounds good. Thanks for having me, and thank you to all the other panelists. It was a joy to meet you all.
Yeah, likewise. Thanks, everyone. Appreciate it.
And just in closing, I just want to throw one thing out there. Do good things. You guys are gonna do great things if you put your minds to it. So, and don't accept things as the norm, because just because we've been doing things the same way for the last 15 years doesn't mean we need to keep doing it that way. So always question everything. And if somebody can throw my my email address out there, I'm on my phone, so I can't really type it in there that easily.
I'll put it in.
Feel free to reach out to me. Do my best to help answer anybody's questions. So thanks, everyone.
Yeah, thanks y'all for having us. See y'all.
Thank you.
So to say thanks for inviting other teams as well. Also always helpful. So thank you. Have a wonderful day.
Yeah, you too. It's great to see other teams.
Yeah, it's fun. It's kind of weird. Like, we'll all be virtual, but it'll be fun.
Yeah.
All right. See you guys.
Yeah.
Bye.
Bye-bye.
Bye, guys.
Bye. All right. Woo!
Done.
We did it. First outreach event of the semester complete. Very exciting. Oh, we should stop the recording.
Oh.